Right. Some of this around. Going. Have to lose the hoodie here in a little bit, but we'll see. All right. Good morning. Let me check one more thing. Okay. Yes. Good morning. Welcome. Thanks to anyone who is watching. For anyone that is new, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I usually stream at this time each week, 10 a.m. Central Time, which is the time for me, working on some stuff related to CircuitPython. What I work on changes from week to week, but it is typically all at least either directly related or surrounding the CircuitPython project in some way. If you don't know what that is, you can learn more about it at the main website here, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers, like the Raspberry Pi PicoW, which I'll be using today. These tiny computers, if you choose to use CircuitPython with them, which is just one of the ways that you can program them, there are lots of other ways as well. But if you use CircuitPython, the way it works, typically you plug it into your computer with a USB cable. It shows up like a thumb drive. You can find a Python code file on that thumb drive, and when you edit it and save it, the microcontroller, the actual computer that's in these little devices, will execute that Python code for you. And then within your code, you can interface with all sorts of other little peripherals that are connected to your device. So lots of these microcontrollers are general purpose. They have loads of I/O pins that you can do different stuff with, whatever you want, essentially. But others are more purpose-built, like this macro pad here has keys and a little screen and a knob, and it's less, it has fewer I/O pins, just general pins that you can do whatever you want with. Instead, it has a bunch of them dedicated to these purpose-built features like the keys and the knob and the screen. That is what we are working on here. As always, CircuitPython is basically made possible by Adafruit. Adafruit is a hardware and software company based out of New York. If you like CircuitPython and you want to help support CircuitPython and people like me who work on it, Adafruit pays us to do that, which is really cool. It's all open source software. Everyone's allowed to use it. It's published very permissively, under a very permissive license, I should say. You're allowed to port your own devices to it. You're allowed to use it in commercial projects. You're allowed to do effectively whatever you want within the license, which is quite a bit. And that is all thanks to Adafruit for paying people to actually work on that code and publish it. So if you want to help support the project, you can do so just by purchasing hardware from them at adafruit.com. They sell the microcontrollers themselves, like the PicoW that I'm using today, most likely is here somewhere. But they also sell all sorts of other little widgets that you can hook up to your microcontrollers. Yeah, there's the PicoW, $6. And then I'll jump to the webcam, and the other sort of hug report thank you that I owe today for hardware is OakDev Tech, which is a member of the CircuitPython community. For those that don't know, OakDev Skur on Discord sells all sorts of little widgets over on Tendy as well. So I got these this week from them, and that is what I will use to test our little experiment today, which gets me into what is the actual little experiment today. So I should have loaded up this URL as well, and I didn't. So let's go here, Bluefruit Connect, GitHub. That is the wrong one. Actually, that's the Android app. I would like the CircuitPython library. So, I mean, I guess the Android app might be helpful to look at as well, or in fact, maybe just images will be helpful here. So yeah, for anyone who doesn't know, the Bluefruit Connect app is an app that is on Android and iOS, and it allows you to interface with CircuitPython Bluefruit capable devices. So the Bluefruit Playground is sort of the flagship in my mind when I think of Bluefruit support on CircuitPython. but there are a handful of other devices as well. This is basically a mobile app that pairs to your CircuitPython Bluetooth device, and then once it is paired and connected, you get a bunch of these options for ways to interact with the device. There are a bunch of different ones. The ones that I will focus on probably during this stream are these two right here, controller and NeoPixels. These basically let you send a color from the phone to the microcontroller. So you can have like a color picker on your screen. You know, you choose blue or whatever. It sends a data packet over to the microcontroller with whatever color you chose. And then, of course, the microcontroller can do whatever it wants with that, such as set the color of some NeoPixels. The other one, controller, I don't know if we can find maybe a picture of it specifically. Does this have... yeah, totally. Maybe? Yeah, there we go. So controller has a D-pad, up, down, left, right, and then 4 other buttons. And these are on your phone screen again. So these show on the mobile screen, and then when you click the buttons on the phone, again, it sends that data packet that says, you know, user pressed the up button. It sends that over to the microcontroller, and of course the microcontroller can receive that and do whatever it wants with it. If it's a robot, you know, maybe it turns some motors on to drive forward. If it is, you know, an on-screen turtle thing, maybe it moves some pixels up and down or left and right or whatever. It can do whatever it wants. And the underlying thing that makes this work is this Bluefruit Connect library. This is a CircuitPython library. It is built on top of Bluefruit, and it receives the data packets that come from the mobile app. And then within your code, you can use this library. And let's say the control pad one. So then you can write some code that essentially says, you know, set up the Bluetooth stuff to be running, do the advertising so that we can connect to the app. And then basically in our while true loop, our main loop here, we go and we try to read a packet from the BLE, you know, from the mobile app essentially. And then we can go and check, was that packet a button packet? If it was, we can get the data out of it. We can see, was it the up button, the down button, left, right, 1, 2, 3, 4. And so you can very easily now make some CircuitPython code that responds to these different buttons doing, again, whatever you want, depending on what your project is. Is there a color one? There's surely a color one in here. Yeah, there we go. So color one works basically the exact same way. It's going to read data from the Bluetooth, and it's going to check, is this data a color packet? And if it is, then you can say packet.color. You're going to get the, well, my assumption is hex value. I'm not actually 100% sure. Maybe it's a tuple or something. I don't know. But you're going to get the color one way or another, whichever color the user selected on their phone. Okay, that's cool. That's what we want to be able to do. But I would like to be able to do it over Wi-Fi instead of Bluetooth, because there are some things like Raspberry Pi PicoW, which does not have support for Bluetooth in CircuitPython. And I think it would be cool to be able to do some of the same basic stuff over Wi-Fi. And my idea for this is that the way this library is written is actually quite conducive to this, because we have this packet class right here, which doesn't extend anything. This is completely decoupled from Bluetooth. This doesn't care about Bluetooth at all. It just takes a stream where it can read from. It will get data from that stream, and then this represents a general version of the packet, which is this sort of predefined data set of what's going to get sent back and forth. And then there are subclasses for each of the other types of packets. So button packet and color packet are the two I am most directly interested in right now. These extend packet, and they allow you to parse the raw data that came in from your stream and decide whether or not it's this type of packet. And then if it is, they can also let you access the data within the packet. So if it's a button packet, you can access which button it was and whether it was pressed or released. If it is a color packet, then you can access what color that was sent over. Looks like, okay, yeah. Still, we don't necessarily know which one it is, but it'll be one of those two, either hex or RGB tuple. We'll see. So this is nice. The way these packets work, because this is all decoupled from Bluetooth, it means we should be able to just reuse this with a different transport layer. If we have a different way to send bytes from one device to another, we should be able to just use this packet thing anyway with it. And even though it's not Bluetooth, it should just work, I think. We'll see if that works. That's my theory, at least. And bringing it all together, the transport layer that I have in mind, the HTTP server library has support, I believe, for WebSockets. WebSockets are not exactly a UART connection, so to speak, but like they could kind of pretend to be a UART connection pretty well. So my thought is we run HTTP server on the PicoW. It's running this server with its WebSocket stuff. It's waiting for someone to load the web page. So instead of a mobile app, there's a web page, at least for this moment in time. Obviously, once the server is running on the microcontroller, then it doesn't really matter what the client is. It could be a mobile app. But we'll start with a web page because web pages are easier to build and we can just write the HTML inside of here. And then it can connect to the WebSocket and it should be able to just send the same data packets. Now we will have to construct the data packet in the correct format from JavaScript, which we don't have the helper code for here. But it should be easy enough because the packets don't seem like they are that complex. So that's the plan. Ready, set, go. First thing we're going to do is plug in the Pico. Maybe. And I'm actually going to just start, I think, with update it. Probably on something very old. Or at least, like, fashionably old. (921). I should have held the boot button. Let's see, you want to see this thing run? Boot button. And reset, because there's no reset button. I'm just going to use the USB hub. Eggs, that seems kind of big. How's it going, Michael Pokusa? Happy to see new uses for HTTP server. Yeah. For anyone who doesn't know, in the chat here, Michael Pokusa has done a lot of work on this HTTP server library. We would not have nearly as many features and functionalities. I think the WebSocket examples was you as well, so none of this really would be possible without your work. So huge thanks for all of the work that you have put into that library for sure. I think this says, oh, okay, it says CircuitPython. That's on my local drive, not CircuitPy. All right, so this is just running the NeoPixel. We will just start with the example from HTTP server. Did that not copy it as text? And let's just run this as is to start with before we get it any further. We'll surely not have the right libraries. I think sometimes this is like a little slow, honestly. Like I think actually, like this thinks it's done, but I think CircuitPython can't see the files that this pasted yet, or they're not complete yet. One of the two, something. I've noticed that before, where like you're pasting stuff and it the microcontroller doesn't realize it yet. Double check. Let's see. Did it actually do it? Let's do refresh this. Actually, that's interesting that it's the Python one. It was already installed, maybe? It was already installed and I have an old one. Okay. So let's just delete that. That again. I say it's interesting that it gave me the Python one, but yeah, I just already had the Python one. There we go. Now we have that. It is MPY. We might want Python if we need to dive into the code, but I think it should be fine. Okay, so yeah, now we have WebSocket servers is fine, but NeoPixel we don't have. That's fine because we don't have a NeoPixel. We are on PicoW. I can use N22. Yes. I just change this to pixels. I don't really need to fill right now. I think I'm just gonna do the first one for now. Okay, does that work? Okay, so that says server is on this IP. Let's tame the tabs a little bit here. I've gone a little bit out of control with the tabs. This is the example. I got it in my IDE, so I'll close that. These we can reopen later if we need. Realistically, we probably want them in the IDE more than browser. We load this page, we maybe get back HTML. Let's see what happened on this side. Not found, so I probably have the URL wrong. Client we need to go to, looks like. Yeah, client. There we go. Okay, nice, we got the page. So this web page came from this HTML right here. This web page, in fact, is this HTML right here. And it will have, in the background, connected the WebSocket back to the microcontroller. And when we select a color, so if I go color picker, blue, select, doesn't print anything there, but in the microcontroller, we got our connect. Actually, we don't see any. Oh, there's no prints. There's no prints, but there is this right here, change to blue. It's fairly bright. Do I set the brightness? Yeah, I do have it fairly low. Okay. The camera, it's a bit too bright for the camera, but it is on blue there. Cool. Okay. So that part works. We have WebSocket going over. And so what this sent was what? This sent the value of the color picker, which is probably just hex. I'm gonna guess that's like hashtag hex, which is usually how it is in JavaScript, kind of. But that was what? Color picker dot value. Yeah, hex. Okay, so that sent a hex string over the WebSocket, and so we do basically want now Bluefruit connect, and then what we can send is like a color packet instead. So I suspect that I don't have this clone, so I'm going to go here and get the URL. It's not going to be in recents because it's brand new. To open it. Recents and choose a random one. And go E for Bluefruit. Really file transfer. This window, we don't need this random driver. So, I don't know if can we do packet? I almost want to do packet not from stream, but like just string or bytes. One of the two. Can we do that? What happens when we call from stream? This wants a raw IO base, which we do. We have that? I don't know what we have actually. What do we have on this side when we receive socket.receive? That is what? Maybe I do actually think I want the Python version just so we can dive into the code as well. So I think that probably just either returns bytes or returns a string, one or the other. I don't suspect that it is a stream implementation. Let's see. In a init. This will import it. Socket response. All right, so that gets initialized. Receive does return either string or bytes. Okay. So we either will want to not use from stream. It might make sense to do like a from WebSocket ultimately inside a packet, but let's see what this does, because realistically this might just call like from string or from bytes or something. From bytes. Create an appropriate object of the correct class for the given packet bytes. Validate the length, the type, the length, and the checksum. So yeah, this we can just use instead of from stream. If we read bytes from the WebSocket or convert to bytes if it's a string, and then pass them to this, it should build a packet for us, I think. So I'm going to copy this to the device. I'm going to import packet. And then inside of here, we're going to change this some. How do we know whether it's going to be bytes or a string? Well, okay, we know we want bytes, so how about we just do this? If data is instance or whatever, is that the right way to do this? No, but it goes is instance because that's a function. Bytes, yeah. If it's a string, then we want to turn it into bytes, which is encode or decode. On string to bytes. There we go. And then we can say packet.fromBytes data. That's going to packet. That's going to return a packet if it works. And then if is instance color packet. Is that where that's at? Dot color packet. If it's a color packet, then get the color from it and set it on the NeoPixel. So pixel 0 equals color incoming packet dot color. So now when we send the data, nothing will happen because we're not going to send the right data. I'm going to do this during initial. So after we get this initialized, I'm going to go pixels fill 0 so that we turn everything off so that we will know when things are actually working as we turn stuff on. Okay, so we're back to off. We have that running. And again, we could go here. We could refresh. It will connect us and we can choose a color, but when it gets received, it won't turn on because we not send the right kind of data. So we got a packet parsing value error exception, unregistered packet type, because again, we sent like hashtag hex color. So I remember what it printed, C, so hashtag C something, blah, blah, to blue. But that's actually good. So really what we want to know is, what is the actual format of this? Okay, let's take a look back here, actually. So the first byte is always an exclamation point. Easy enough. The next byte is a single byte that designates the type. Either A, B, C, etc. Capital letters, looks like. Well, any byte, I guess. And those just happen to be ASCII. Okay, data is multiple bytes of data varying by packet type. Checksum, single byte. Adding up all the data. Inverting the sum. Inverting. I don't know what that mean. I don't know what they mean inverting. If that means maybe go to binary and then invert which bits are ones and which ones are zeros. Not sure if that's actually what it means or not. Ability to. Why would this be partial packet? Oh, because it doesn't count as a full packet until it has the checksum. Okay. Right. Let me just check. Is this actually like the bits thing I was talking about? Int is not iterable because we would need that to be bytes. No. Well. No. It's kind of, well, no. The sum of the bytes and then all the ones. I don't know what is tilde doing exactly here. The sum of the bytes. I mean, realistically, we can. When we do this, and can we do this in JavaScript? We can think, but I don't know. JS byte array. I'm kind of messing it up by not really having a full array, I guess. So our sum is just one value, but I would like to understand how it's working with one value before I get into summing as well. Return. I mean, really? Deuce? Surprised there's not a thing built in for that. Or a little bit. JavaScript. Five. That does not make very much sense. Okay, off to a good start. Check some. Let me reread this again. Sometimes just rereading stuff helps. A single byte computed by adding up all the data and inverting the sum. Inverting the sum. Also, one thing we could do is we could try to ask the old Edge robot if it would mind explaining this a little bit more for us. Just one step at a time would help. Ah, yes, you do have to send it the code you want to do. Sum the packets, calculates the sum of all the things. That part's easy. Bitwise and... So... Yeah. Okay. So we're only taking the last 8... Okay. We are going to binary. We're only taking the last 8 bits. Did it just... doesn't seem to have done the tilde. Unless... Doesn't seem to have done the tilde. Probably messed it up by not actually including the code. Then I just messed up the question mark also. It was not. Okay, that is going to take the opposite. So that part I had, it's just the 8. So we need only the 8 bits at the end. So does JavaScript have the AND JS bitwise operators. Does it have and not? Yeah, so those should both work. And we have our sum thing. I'm not sure here, though, why we would have gotten that. So the sum of that should be 5, but it's not. So there's the first problem. That thing doesn't work. Unless this doesn't actually have 5 in it? This doesn't actually have 5 in it. How does this... What? So do not understand JavaScript sometimes. Is that not how you set things in a byte array? How can I... this change? You have to give it a list to start with, and then you can change stuff. You can't just give it a size. I give it 0. It's not gonna want me to reassign it. Now this is gone. I mean, I don't really need it though. We don't have the sum anymore. Alright, we'll move into the HTML page here pretty darn quick because I don't want to go through all these every time. I want to kind of get my JavaScript bearings a little bit to even know what I'm doing before I get in there. Okay, so that is now the correct sum. And that is 250 instead of 255. Okay. I think that should be correct. We could call packet.checksum with the bytes of 5, a single byte array with 5, and we could check. But you need... No, that's static. Okay, cool. So we can just say packet.checksum. But we do need to import it. Is it underscore? No. $250. Nice. Should we test a more complex one or just send it? Let's just send it. I think it's fine. Okay. Let's make us a function checksum. Do I really need to use byte array? Can I not just use a list and like, as long as I pinky promise not to put things bigger than 255 or smaller than 0, everything should just be fine, right? Data. We need that sum function. What's up, Johnny? Nice to see you this morning, my friend. Today, my friend. All right. So we can do a checksum, maybe. Oh, we can calculate one. It might be correct. The next thing we need to be able to do is create the rest of this packet. So we know we're going to have an exclamation point. I'm going to guess we're going to have a C for color. Is that accurate? Oh, we could create a color packet from a color tuple and then just print it out. Which sounds way easier than like trying to read the code and figure out exactly how it's going to be. What's up, DJ Devin? Nice to see you today, my friend. Color packet. Putting some cable channels in the office so I can connect all my displaying devices on the shelf. Nice. Getting the old office improvements. Always nice to get some new stuff going in the office. Color packet. So if we say color packet, well, we would initialize one. So let's just say C is color packet. That said tuple. Okay, 2 bytes. Okay, exclamation point, and then a capital C, and then it looks like just hex bytes that match those, and then the checksum came out to 9D. So we will need to do byte strings. Is that a thing? Yeah, looks like it. Wait, I came back to here. So probably this would be easiest if we had like function create packet and this took a JS color. Which would be the hashtag version. So we need to basically convert those to, we need to convert a string color into a hex color with like numbers. Oops. Okay. Name, that's not at all. That's looking better. Could eventually move this to its own file, then we would get syntax highlighting, which would be kind of handy. Also working on shelf stuff, adding 8-foot vertical 2x4s to the back of my workbench to add plywood for shelving. Nice. Can't screw into the wall because it's made of wood veneer and plastic. Create my own kind of. 137. Let's see, did this just set a goal? Yeah, for one thing, that can go away. Was that the problem? Just have typing in there when we can't really? Load. Yeah, okay, so we just can't have random typing when it's not actually TypeScript. It. Really want randomly this to be declared differently than function. So I'm just gonna say useless name for a variable that I can think of. All right, does that work? So let's save this. Let this run. Load the page. Right, that's still an arrow thingy, which it can't be. Get out of here. We don't need your arrows. Okay. What is it? Color. What is it? Convert? String to color. Allure. So I did not do it up. I don't know. That. How do you, can you do Edgebot will be good for this. Okay, this is whoever's brilliant idea to make this pane just stay here and then sometimes get stuck not rendering even though it like exists in every tab at once. Wasn't the coolest move, I don't think. Really, I don't think this needs to be its own pane that exists in all the tabs. The tabs are supposed to be different, that's why they're tabs. Okay. User interface ranting over for the time being. And you show me JavaScript code. JavaScript code. Convert a color string like into a byte string into a string containing appropriate byte values for the color. Okay, that seems like what we want. Thank you, friendly Edgebot. The extent that this does what we want for real. Full. Color to byte string, so that takes the color. It checks if it starts with the hash. If it does, it slices it off. If it's exactly 6 characters, if it's not, throw an error. Split out the components, so these will be like FF for red, 00, and then FF for the pink that I'm doing. take each one of those, convert it to byte string by using... Oh, interesting. I didn't know that was a thing. ToString. Is that a thing? That's a thing. Interesting. So you can go... So a string, like FF, you can go ToString 16. That's not very useful, though, is it? Oh, this is a number. Okay. That's kind of cool. I didn't know that. ToString takes a base. And then pad start to make sure we get zeros if it's not very big. Cool. Okay. Byte string. Yeah. Easy enough. I mean, kind of. I don't know. Maybe it could be easier, but... Just running? All formed. That's no good. We got a bit ahead of ourselves. All formed hexadecimal character escape sequence. Does it need... Well, because it's using... I didn't mean to do... Formed... Better at Python than it is JavaScript? Aren't we all? Boy, that really is an interesting way to format that. No. Really doesn't like that. JavaScript. Why must we be like this? Maybe that could work. Can we go from a number to a byte string? That's not what we want at all. It feels like byte string is not a thing. Is byte string like not really a thing? Should I be not worried about that? Should I just go to a string and call it good? But it seems to really hate having these in it. Who knew this would be the hardest part so far? All right, 2 bytes takes a number. Byte length is not defined. What is that usable somehow? How do I do anything with that? No. And JavaScript, not jive with JavaScript sometimes. How can I, it really does not feel like it should be so hard to just get a byte string of numbers, right? I don't know. How do I get a byte string? What even is an array buffer? Generic raw binary data buffer. So how can I get to a string from that? Okay. Boy, this is kind of really annoying, truthfully. I do not think it should be this hard. And it's probably just me, I'm ignorant of the correct way, the easy way or something, but I feel like it be more obvious than this. You know, but like, so like byte strings exist insofar as this represents a byte? Is that true? Or am I like not even accurate about that? Could be in front. Not like that. In JavaScript, though, we are in JavaScript land. Because, like, I'm trying to send the byte string from JavaScript to Python. Okay. Maybe let's try something slightly different for a minute. What if we just hard code this to see if we can even get one color to work this way? All right, so exclamation C. $9D. Let's see if that actually changes color or not. Or I don't even know if we have color changing code, but let's see if that crashes or what it does. You have to pick a color. It's going to ignore what we choose. Got closed. Wrong length. What did we receive? Nice. Okay, that put the slash in everything, I think. No, I have absolutely no idea what that did actually, because we don't even have FF or 00 in here at all. We got 9D though. That's interesting. I had some 2 bytes helpers, but my color packet passed in RGB. Oh, yeah, totally. This is already a JavaScript implementation of the packet. Payload packet length. Yeah, thank you. Not well tested, half-assed backwards. The rest of that is serial. Bytes, packet. From. Send bit is way later after the hooks on 814. String packet. Oh, right. String packet is a different thing. Raw bytes. I don't want to bring async into this quite yet. I don't have very much. Oh, it looks like we already have. Well, on the Python side, we have. In the I want to avoid it for now in the JavaScript code if I can, because I don't have much practice with it, and I'm already struggling. Okay. What if we don't do that? What if we don't do this? Like, did we, first of all, did we get a string first? Print type data? And I'm just going to turn this off, actually, for right now. And it's going to break something else because it might not be bytes. Unfortunately, like, my JavaScript is not great and is somewhat ancient. I don't type. I don't have a lot of practice with more modern JavaScript. I don't. Yeah, they're definitely not bytes we need. Okay, let's. Do I want to do this? It's going to add complexity also in another way. Is it source or href? I don't want to do this. I don't want to do this. It would be convenient to have this separate, but this is just introducing more nonsense because it's going to have to make another request and serve another file. And like, I'm already layers deep in stuff going wrong. Array buffer like. Array buffer like. Can we just send... So array buffer like, we had that earlier. Where did I get this from? I don't remember which thing now. I've tried too many things. We had an array buffer like, though. We got it from something. I have too many things. I have no idea where I got that from. Reached critical mass here. Byte array. Maybe it was from this 2 bytes number, but this really, I don't just want one. I guess we could go through the list. Maybe this can actually just work for us though. I didn't realize WebSocket could take a array thing. And I was stuck in the string mindset. X 2 bytes. What on earth? Oh, okay. We can close. I thought that's the file I was in for a second. I was like, how? Oh, I'm not even testing the right thing. X. Get the numbers for strings. ASCII. Okay, so 3, 67, 255, 0, 255, and 157. That should be the numeric values of a color packet for pink. But what if we just did a list with those in it? Would that work? $33, 67, 255, 0, 255, checksum, 90, 157. Was that the correct checksum? Yeah. Okay, I gotta run to the restroom real fast. While this reloads, and then I'll be right back. Okay. Color. Unregistered packet type. So we got a string. I mean, I don't hate it. We can convert those back to bytes on the Python side a little bit easier. Sounds like renovating some built-in wardrobes in a lab, found at IKEA shelves. Found that IKEA shelves fit perfectly inside. They're both sturdy and cheap. 3D printed some brackets to distribute the weight. Nice. Then masonite for the wall. Sounds similar solution. Got some large standing wardrobe-esque metal cabinets. I don't even have room to set that up yet. Okay. That can deal with on the Python side where I am a little bit more comfortable. We can just go and go that will give us a list of integers. And convert from a list of integers to a byte string by just doing what? This should be really easy, I think. 2 bytes. That is beautiful. Yeah, just even bytes. That's super easy. So we could say from bytes, bytes, numbers. Numbers? Numbers. Print all of those out so we can see what happens at every step. Oh, it came on. It worked. Bam. Pink. Okay, it's hard-coded to pink. Let's make it do the color picker. Which, that's easy now because we have this thing which gives us these list of numbers. We can just... We have list, which is super easy. We can just add things to the list, right? So we know we always start with these. It's a bit strange that WebSockets receive text. What do the dev tools say is being sent? I don't know. I mean, like a literal list is what got passed into ws.send. I'm not entirely sure why it turned that into a string. But honestly, at this point, I want to just take the win. So I'm going to keep plowing ahead with it, even though it's kind of weird to send a string comma-separated list of numbers as bytes, right? I get that it's not efficient at all, certainly. But it's functional, and I'm happy for functional at the moment. That is super weird, though, that it... I mean, I guess it just called... It must have just called toString on this, right? It must have... Because that must be what JavaScript does, right? If you... I would assume so. If we said, like... Well, it is weird that it didn't have square brackets, actually. That's the part that's weirdest to me, because wouldn't... So, like, L... 1, 2, 3, 4... Whatever, right? And then L dot toString... Oh, that doesn't include the square brackets. Yeah, it totally just called toString on the list. Which is not the best, but it works, and it gets me out of JavaScript land and back into Python land, and I'm happier there. 2 bytes on the list. Is that a thing? Let me see. 2 bytes on the list. No 2 bytes on the list. But that might not be what you meant. Is it 2 bytes like this? Or is that one of these functions? Hexabytes we have, but that's a little different. Oh, there is 2 bytes right here, actually. Oh, but that takes only 1 number. If we had one of these that was like a full list instead of a single... It is weird, too, though, because it's taking 1 number and then creating an array... I don't know what that one's doing exactly off the top of my head. I was thinking uint array. I gotcha. Okay. Let's hook up the color. So we have color picker.value, which is the hex color code. What we're gonna do is data list is a list. We can start it with the ones we know are there. What's up, Saifu? I don't know if that's the correct way to pronounce your name, but it's nice to see you over there on Twitch, my friend. So we can start with those. Let's see, the price of lumber has come way down. Oh, that's good to hear. Yeah, I heard a couple of times over the last couple of months. I don't do a lot of woodworking myself, but I have definitely heard people say that lumber was getting pretty expensive. That looks pretty sweet, though. I like your setup there, with the desks. Could use something like that in the basement. It would be pretty cool. Okay, so we've got those 2. We can... Is it extend how you add 2 lists together, like l.extend, or is that Python? Is that Python? That might be Python. Can you just plus? It's JavaScript. You might be able to just plus? Nope, that's giving us strings. How do I add concat? That sounds promising. Yeah, that's the one we want. Concat. So we have data list. We go data list dot concat with hex to bytes, right? Yeah, hex to bytes. Should rename that color, because really it's not just arbitrary hex. It's like specifically a hex color code, a hashtag followed by 6 digits. Color picker.value at oh, that. I guess, does it return a new one? It does. So let's say data list equals And then we need to get the checksum, so we can say data list dot push to add the checksum passing in what we have for data. I like semicolons with my JavaScript. A lot of this code doesn't have it. Some of this code doesn't have it. That's fine. Okay. Let's say green. No green. Okay, what did we get here? Got no error on that side. Got nothing, actually. Okay, let me reload this. Did we send it? Or if we sent it at the end, actually, come to think of it. Well, yeah, we definitely didn't, because we are still sending this one. But the next problem is, though, it didn't even, it's not, this one's not even working anymore now. Oops, that one says something about inner. Array is not defined. Data. We had byte array before. We don't anymore. We just data. Siafu. Siafu. Everyone gets it wrong, no worries. Does have this? I think that matters. It looks like this gets called once when the page loads, actually. Maybe. Okay. We're back to pink works. But that's because pink is still hard-coded. What is our... What did it print? Well... Didn't actually print anything new, though. Did it? Print anything new? Did it not print when we chose green? Ah, because this function is not... Okay, we need to do this when this gets done, right? This is like one of these, and this is wrecking me here. I think we need, yeah. Let's change this. Or my speed, I think. All of this should be in here. Is device workspace a VS Code extension? It is not. Device workspace is just the name of the folder. I have a folder called device workspace, which is on my hard drive, And inside that folder, I'm in PyCharm as my IDE. Inside that folder, device workspace, that's where I point my IDE at. But I also have it set up where I think it's called project structure source folders. Like basically it also looks at connected drives, which is in my case on Linux show up in MediaTempC. So it will find my CircuitPython device that is connected over USB and it will drop it here as well. But it also gives me all the stuff that's on my PC, which is mostly backups and test scripts and stuff. If you are interested in CircuitPython and PyCharm, like basically my exact setup is the one from this guide. Welcome to CircuitPython Advanced. It's a little out of date. It's on my list to go back and update it. But my exact setup is basically on this page. Nope, don't need that, thank you. I believe something like that would avoid calling toString, then you, let me catch. Oh, send bytes from a uint8 array. Oh, wacky with the extensions here. Let's uint. So you're saying basically if we did at the end of this data list equals u int 8 array data list, then here's our hard-coded one, which we won't. I will say that now our code on the other end will probably break, right? But that's fine. We can fix it on that side. It'll be even easier this way. Oops. Besides being able to screw on storage cabinets, I want to be able to mount my 12 matrix panel to the wall. Nice. Maybe Fruit Jam to be able to play some retro games on it. Unsure if 12 panels will be compatible with Fruit Jams. So I don't know about the sizes off the top of my head, but one of the things I was experimenting with a little bit yesterday was USB capture, a USB capture card, like an HDMI USB capture thing. There's one on the Adafruit store, in fact, that I was using. I was capturing a switch, and I was sending it to the panels by way of a Raspberry Pi 5. I believe, though, I haven't tested it, but I believe you should be able to plug your Fruit Jam in here. This is in the Pi 5, and then the Pi 5 can drive the matrix panels for you. And I believe that should work. The 200 should not be sent. It's an argument of debounce. Ah. I messed that up. Right. Why is this debouncing? Does the color picker pick really fast multiple times or something? I have an HDI capture dongle, the same one. I do have an unused Pi 5. Sounds like Jepler made some progress. Yeah, definitely. He's done a lot of good work to get the matrix panels in the Pi 5 going. And it did just get faster too with frame rates, although it was already fast enough that I could not see any difference really from the screen. With Doom and Pico 8 were the two things I tested. And a Super Nintendo start screen. I couldn't get my controller working. I couldn't play the game, the Super Nintendo one, but the start screen plays the animation of Donkey Kong. Let's see, there's that. Okay, still learning my way around VS Code. I've only used it with and for the NRF Connect. If me, I had touchscreen issues to debounce everywhere. Oh. That could be, yeah, from the phone, I guess. That's a good thought. On Chrome, it does pick very fast if you... right. Yeah, so that's... I gotcha. That's the thing. Different browsers have a different default color picker, right? So this is... I'm in Firefox right here. This is just a input type color. Which it's really cool that browsers support this built in now. But every browser does it differently, which is less cool. In Firefox, you get this nice grid, which you can pick from. There's a custom one, which you could go and pick. In Chrome, it must be like a live picker, and it changes as you scroll the bar, it sounds like. Makes sense. I do it. Maybe one day that will be standardized. That'd be cool. I should just be happy that it works, though, across browsers. Like that each browser has one. Color picker is not defined. Maybe I'll get rid of debounce for right now. Color, oh, C Lawler picker, nice. Lawler, classic. All right, there we go. All right, let's do green. We'll at least pretend like we think it's gonna work. Did not work. That's okay. Oh, because we didn't, let's see, calling a built-in typed array constructor without new is forbidden. I probably didn't put that in right. Or maybe it just needs new. Yeah, no, I didn't put it in right. So this would be new. Oh, let's call this data bytes. And let's send data bytes. Print it also. Right here, so we got no error on this side. And again, though, yeah, I haven't changed the parsing code. Class bytes. So that is from what? Convert string to bytes implicitly, 163. Yeah. But it printed type of data, which was bytes. Let me print data itself. And then this is going to crash again, but that's fine. We can see the data at least, and we'll see if it's the correct byte string, which it's looking like it might just be the correct byte string now. How about the bit in the middle there? Let's try it. I don't necessarily think that part is right. But the first part is, which is interesting. It looks like you're bouncing between Python and C. I'm not familiar with CircuitPython, always been curious though. I am bouncing back and forth right now, mostly between Python and JavaScript. Let me clarify, between CircuitPython code. So this CodePy here is CircuitPython, which is running on the Raspberry Pi Pico here. So that is CircuitPython code running on that device, and then in my case, what that code is doing is hosting an HTTP server which is serving this HTML web page, the bulk vast majority of which is all of this JavaScript right here. All that being said, though, CircuitPython itself, the actual program that allows this microcontroller to interpret this Python code here is CircuitPython, and that is written in C itself. So the CircuitPython core is C, and it implements the CircuitPython language, which gives us the ability to write Python code and run it on the microcontroller. And then HTTP server library allows us to also serve HTML web pages, which can execute JavaScript in the browser. From bytes, so let's just say data. Keep this one in case we want to go back to it. I don't think we can do this for thing, can we? Extra bit is space. But I have 12 panels, so the faster refresh rates will likely show more of an impact. I never used matrix panels on a Pi. Last time it was Pi 3 for a Pi whole. Oh, that's awesome. JavaScript syntax looks a whole like C at first glance. Yeah, especially for sure with the bit manipulation we're doing as well. Definitely makes it look C-like too. Although I guess we're not doing as much of that on the JavaScript side anymore now that I think about it. Oh, it worked! It actually worked. Oh, we're not sending pink anymore. I was looking for FF00FF, but we're not sending pink anymore, so that's not the values. So those were totally fine. All that stuff was correct. I was just looking for the wrong thing. Yeah, totally. So we can send colors. Okay, that one didn't change very much, but that's fine. We can send colors, and it updates the NeoPixel. That is so rad. All right, a few more. A few more. Gotta enjoy the fruits of our labor here. Sweet. Okay. Thank you, by the way, Michael Pacusa. Again, that was exactly what we needed. uint8 array that allows us to send actual bytes across. So let's clean this up just a hair. Get rid of some of this stuff. We don't need that. We don't need this. We can keep printing those. We're gonna get rid of this. Okay. And then on the JavaScript side, let's figure out what we actually need from here. So I'll make one of these eventually, I think. Maybe. Did we end up using all of this? So we definitely use some inside checksum, and we definitely need checksum for the data we send. This stuff is commented out. We're not using it. We can get rid of it. Color to hex we're using, so that takes in our string hex color JavaScript style with a hashtag and gives us back a list of ints, kind of 0 to 255 basically. So I am hard coding this to color packet, but that's fine. This is a color picker example. So this stuff here would basically be the code inside create color packet. Create packet. Let's call this create color packet. And bytes. then here, this can be, well, JS color, this should be this. I mean, doesn't matter. We can get it from color picker. I don't know. This makes it more functional or whatever, right? Because we're passing it in. So then that would be create color packet from color picker. That works. F key. Nice. Okay. Let me see if we can quickly add one more button to the page. I'm actually just going to use a button. And I don't know that we need a paragraph for it, really. That's not broken. Okay, so then what I want to do is when we click the up button, let's have it send a up button packet. I'm just going to hard code it for the moment. So we could do something similar here. Random extra curly bracket there? Sure, right? Yeah, I think so. So then this one, we want to send a I'll do actually, let me just copy this for now. In packet. Probably that's going to be 66. I'm guessing, because it will probably be a B for the button packet. We pass into that. Button as a string and pressed as a bool. Single character denoting the button. I guess these probably then? So 5 for up. So new button packet 5 pressed true. Button, oh right. Okay. B.2 bytes. Okay. So that is looking like it is definitely the B, which should, I presume, be one down from the C. And then the button we want, I'm guessing that's 1 or 0 for pressed or not pressed, and then the checksum at the end. So if I want to hard code for right now, the up button, we're going to say exclamation point, capital B, yeah, right? Yeah, so the string is the constructor. The string is the constructor. We're not using the constructor here. We have numbers. We push 5. We push 1 for pressed. We put a checksum. Yeah, that should be the up packet, I think. So let's say when the up button is pressed, ws.send create btn packet, which does not take any values, actually. And then on the code side here, let's say when this comes in, elif is instance incoming packet or a button packet. We will, let's keep a variable called per index. Per index starts on 0. When we receive a color, we're going to set cur index to that color. When we receive a button packet, right now it's hard coded for up, so I'm just going to handle only up. So what I'm going to do is temp color equals pixels.currentIndex. Then we set that to 0 to turn it off. Then we go current index plus equals 1. If we want to be correct about it, we could wrap around. So plus 1 and then mod. We happen to have 50 LEDs, so mod by 50. So we wrap around and then set that to temp color. So move up by 1 index in the NeoPixel chain. That does what I think. All right, so color, blue. Nope, we broke it. Local variable, reference before assignment, 185. No, 185. $159 per index. Just yet. Not exist yet. Well, we need global? Do we need global? This is like all messy because it's got async functions. We should really have like an object or something, I guess. Why is that mad? Expected types? Oh, this can't be data. Context. I like context for the name of this, actually. Still. Oh, did I? I don't think I refreshed. Not sure if I refreshed. I don't think I refreshed. Those are working. Good there. We go up button. No dice. What do we get? Oh. Oh, it closed. Okay, so we crashed. Add button. Press release value. 1, 6. Bad button. Press release value. Why is 1? 1 should be fine. You know what? These are ASCII. Or something, right? These are like literal ASCII, right? Yeah. And we're putting in bytes 5 and 1. But we need, I guess we need ASCII of those. So 53, 49. JavaScript side. Probably a way to convert those, but I'm just going to hard code them. In fact, JavaScript being how it is, it might just work if you did that, but I'm not gonna. So we want 53 and 49. 3, 49. Oh, it worked. I lost faith for a second. Nice. It does seem a little slower, if I'm honest. Oh, the debounce though, right? We have the debounce, which is waiting 200 milliseconds. Nice. And we should be able to change. Can we change the color? Yeah, totally. Sweet. All right, I think that's probably where we wrap it up for the day. I am pretty darn happy with that. So now basically we could, in the web page here, we could make the button page with the D-pad and the 4 buttons, and we can make a color picker. And I'll try to probably look at the app if I can and mimic the one that's in there, because theoretically, like, this web page now can be a page of the app, essentially. You can open this in your browser on your mobile phone, assuming you're on the same Wi-Fi network as this. And then you could, like, we could make it, if we get this page looking good enough, you could see basically the same thing that you see in your phone in the app now. What's an up button? Yes, up arrow. Yeah, D-pad, exactly right. Yeah, so if we do where's that Bluefruit Connect Learn Guide? That had the best picture, I think. Fruit Connect. Nice. Wow, these are very big. That's the thing I'm imagining. That's not the guide that I was, there it is. This is the guide we were looking at before. NeoPixels isn't published. We basically will have something like this on our page. I was just hard coding the up button to get one of them working. Yeah, I think this is actually super cool. I'm glad this worked out as well as it was. I had to fight JavaScript for a while there. Huge thanks again, by the way, Michael Pokusa. I appreciate the help with the array there. That actually did make this a lot easier. This, I think I count this as a successful proof of concept. I don't really see any reason why we couldn't implement all the rest of the packets essentially and kind of build on top of this transport layer. And essentially have a functional same API as Bluefruit Connect type thing going on. I'm just using these LED matrices because it was convenient to test. I knew that I was going to be sending colors and then ultimately D-pads, so I figured setting the color of the pixels and then moving it around the pixel would be a good test. So that's just my test, but it could be used for anything. That's the cool thing about Bluefruit Connect here, is that once you have this connected on your microcontroller side, your code can be whatever you want. So in my case, I do have interacting with NeoPixels here, but if we had a robot, this could be, using the D-pad to spin motors, or if we had a game or something, this could be using the D-pad to like input to the game. So Bluefruit Connect itself is super general. You can use it on the CircuitPython side for whatever you want. And that mobile app is just like a general send a color or send these buttons, and then do with it whatever you want on your own side on the microcontroller. Well done. You don't really need a debounce for the web page. For the button especially, yeah, we definitely don't need it for the button. The color picker, I think we want to keep because of Chrome, the way the color picker works there. The button we don't, though. Yeah, I just did that to keep it the same. I also didn't pass a number here, so I don't know what the default is. But yeah, we don't actually could get away without this. Pretty sure, right? You just do that and it should work fine. Yeah. So then in Chrome, I think as you slide that bar there, as you slide that selector across the bar, it sounds like it's sending the on select or on whatever we're doing here on input. I wonder if there's an on select one. Anyway. But yeah, LED matrices, you could use it for that, but you could also use it for all kinds of other cool stuff. Use it to change the color of an LED candle. Nice. I don't think I have a guide on that, but yeah, you have to hard code the colors. All right, that is going to do it for me today. Thank you, everyone, for watching. Thanks for all the folks in the chat. It was nice to see all of you over on Twitch and Discord. I will be back at the normal time next week, as far as I know, 10 a.m. Central Time. I'll be here streaming some more CircuitPython stuff. I think that I might be around for Deep Dive next week on Friday, but I'm not 100% sure. I gotta check in with Scott this week. He was going to be out for a couple of weeks, and he ended up having to change his plans a bit, so he is around some, but still recovering perhaps. So I'll check in with him. We'll figure out who's doing a deep dive. So it might be me around on Friday. In either case, though, I'll be back at the normal time next week on Saturday, 10 a.m. Central. We'll be here. Thanks again, everybody, and I will see you later.